Welcome to the Funnel Reboot Podcast with your host, Glenn Schmeltzley. Let's get into today's show.
Hey, Glenn here. Welcome to Funnel Reboot. Let's get straight into today's show. Today's topic is AI and ML. And though you may think this doesn't concern marketing, we need to acknowledge how it's going to shift things. Up until now, marketing was done on the premise that for a given audience shown a message, some average percentage would act on it. With AI, we're now able to look at individual audience members and predict how each of them would act upon a message and the opportune moment that we could show that message to each of them. Goodbye analyzing what happened with crude audience averages. Hello to using detailed data to predict what's likely to happen in a particular instance. With AI holding such promise, why don't more companies hand things over to AI? I had thought it was held up by a lack of technical people who know how to do it. But our guest says we've had enough of those people. He himself was previously one of those data people, and his expertise wasn't enough to do the job. He says AI initiatives are held back by those running business functions like marketing who haven't made the business case and who haven't collaborated with the data people to bring it home. My guest is a leading consultant and former Columbia University and Darden University of Virginia professor. He's the founder of a long-running Machine Learning Week conference series, a frequent keynote speaker, and the author of both Predictive Analytics and, in 2024, the book, The AI Playbook. Let's go talk to Eric Siegel. Eric Siegel, welcome to Funnel Reboot.
Thank you, Glenn. It's great to be here.
Thank you for coming. Eric, we're going to talk about the AI Playbook, and we want people to understand what can really be pulled off when they bring AI into their organizations. But I think one of the main things we've got to hit right up front here is that we're not trying to describe magic. We're trying to describe something that is going to have an everyday impact in an organization. And the way in which we bring that about is using everyday people. This is just, there is some technicality to it, but what we're really doing is rather simple, or even what we might say mundane. Can you tell us a little bit about that?
Well, predictive analytics, predictive AI, enterprise machine learning, whatever you'd like to call it, is technology that learns from data to predict whether each individual will click, buy, lie, or die, commit an act of fraud, turn out to be a good or bad credit risk, any outcome or behavior that could be valuable for the organization to predict in order to improve organizational operations, which consist of many decisions. So who to contact, approve, test, warn, investigate, incarcerate, set up on a date, or medicate. So in marketing, that's largely whether they'll buy, whether they'll respond, or whether they'll cancel or quit if you're trying to target retention offers. In most of these kinds of predictive use cases, these enterprise use cases I've quickly summarized here, the thing you're trying to predict, we don't, as you said, it's not perfect. We don't have a magic crystal ball or clairvoyance, and we can't expect computers to either. But what we can do is predict better than guessing, and in that way tip the odds and play the numbers game that business consists of much more effectively. It turns out you drive an incredible improvement to the bottom line of these types of operations and marketing campaigns by integrating probabilities, and that's what you learn from data. That's what machine learning does. It creates a model, and the model outputs probabilities for each individual case, person, transaction, B2B client, corporate client, satellite that might run out of battery, whatever the organizational unit that you're operating on. And it's going to output for that project, whatever outcome you're trying to predict, a number. And the higher the number, the higher expected chance that they'll show that outcome or behavior. And that is the holy grail for driving organizational decisions.
Thank you. And I'll bring you back to that part you said about being better than guessing. How I came to know that was through reading your first book, Predictive Analytics. And in there, you gave a kind of a great origin story. And it's probably the signal event that caused a lot of us to first see AI come up, and that was Watson playing on Jeopardy. Something just to point out on that, that was what, in 2010? That was so your point about AI not being, a magical crystal ball that just pops into existence. This thing's been brewing for a long time. IBM's Watson wasn't trying to score a perfect game of Jeopardy. What IBM's Watson was doing was beating the other contestants. And that's exactly what you said just there when you said, we're trying to make things that are predicting outcomes better than the way that humans do it right now.
Yeah, exactly. I mean, Watson didn't just predict what the right answer to each question. Yes, on the TV quiz show Jeopardy, it's framed as an answer and then you pose it as a question, but that's just on the surface. It's really they're asking a question and you provide a one term or one name answer. And Watson is predicting, so it's the same underlying technology and the same underlying technology, machine learning, that learns to predict, also drives today's generative AI, including the chatbots like ChatGPT and image generation. So in the case of Jeopardy, what it's doing is predicting, hey, given this question and this candidate answer, who was the first president? Abraham Lincoln. Then it tries to predict how likely that's the correct answer. And it tries it again with George Washington. And whichever one has the highest, it's going to say, well, that's the if it's forced to provide an answer, it'll give that answer. But it's also got that confidence level, that predictive score. Right. So it can decide whether to try to buzz in depending on other pragmatics around the context and during gameplay. And that's exactly what happens with all these enterprise applications, that you've got that confidence level, that score, that probability. So you can decide whether it's worth spending $2 contacting this person for marketing, or whether it's worth spending $200 in investigating this piece of equipment as potentially something that's going to fail, or whatever the operation is. And in chatbots like large language models like ChatGPT, it's predicting what should the next word, or it's really technically it's a token, but it's on that level of detail. What should be the next word to write? And then once you've done that, well, now I've written 75 words. What should the 76th word be? And it keeps doing that. When it's rendering an image, it's how should I change this pixel in this context during this next iteration as the computer is rendering the image. So it's all these different ways of using the same core technology, which is machine learning from data to predict.
So it's doing that. Yes, we see examples all over the place now of where we can do that. The time has come for not only enterprises, but for everyday businesses to be able to have this same kind of technology at work on what they're doing with that laundry list that you gave us. You start off in the book saying it would seem self-evident that every company would want to just get going on this today. And yet we live in what someone very well known in this field, Clayton Christensen, calls the innovator's paradox. And that just having a great disruptive idea ain't enough to necessarily get everybody, including our senior management, saying yes to it. So what's the warning that you're sounding there for people who are saying, well, yeah, let's just kind of green light this and hit the gas?
Yeah, so let's put aside generative for a moment. Predictive AI is the kind of stuff I've been describing so far for the most part. It's been around for decades. That's where the established track record is. But even there, there's an even higher rate of failure. Most new machine learning projects fail to actually achieve deployment. And there's a lot of, and this sort of goes hand in hand with the nature of hype. So there's a lot of excitement about the core technology, and it is the coolest science, in my personal opinion. That's why I got in the field, and that's why most data scientists get into it. This idea that you learn from data to predict. You've garnered something true automatically. The machine has garnered something true from, and what I mean by that is that it now will apply and pertain to new cases never before seen. It'll be able to predict for this customer in this situation, what are the chances that click on this ad, click buy, lie, or die, whatever the outcome you're predicting is, with oftentimes the same performance that you established during the development of that predictive model in the first place. And that's amazing. That means it's discovered something that holds true in general, not just over the cases that were analyzed, not just the number crunching examples. So that is cool, right? And then you put the moniker AI on it, which kind of anthropomorphizes and heightens expectations, usually oversells them. And
Yeah.
all of a sudden, we are fetishizing the core technology, which is kind of like being more excited about the rocket science than the launch of a rocket.
Yeah.
So, if you're really into the rocket science, which is what some people are, you might say, this is so awesome and cool. Who cares if we ever launch the rocket? But at some point, the business does care whether you deploy. And by deployment, in this case, we say, we mean changing the operations, actually driving decisions, affecting them, changing them, and thereby improving them by integrating those predictions, those probabilities. Those numbers now have to make a difference. It's not business as usual. This requires a change. That's the last step, right? Or not the last step, but it's the culminating step of these projects where you actually put the pedal to the metal and make a difference. And it turns out that ends up being that a final step that never gets done. Basically, stakeholders, because their hands don't get dirty, their feet get cold. So the antidote, and the reason that I wrote the new book, the AI Playbook, is to outline the business process needed, and I outline it as a 6-step practice called BizML, business practice for running machine learning projects, so that you'll succeed, not just technically, not just analytically, quantitatively, scientifically, but in deployment. As an enterprise, you'll actually capture value more than just generate that value by actually acting on the predictions, by getting it deployed. And the bigger theme is, everyone has to understand the sort of steps, not just the technical step, but the enterprise project steps, the paradigm, the framework for running these projects. But the bigger theme is that this needs to be a very deeply collaborative process between the quants, the data scientists, and the business professionals. Let's say the line of business manager who's in charge of an operation that's meant to be improved with a predictive model. That collaboration can only be done if people are on the same page as far as what the overall practice is, but also if the business leaders and the business professionals involved in weighing in on, touched by the project, have ramped up on a certain semi-technical, not the rocket science part, but how to direct that rocket, how to steer it. A semi-technical understanding of what it means to learn from data to predict, and then to apply those predictions to change operations. So that's the bigger point, and that's the bigger reason that I wrote the book.
You say that, frankly, the progress of this field may have been dampened a little bit by the fact that the quants had been the ones possessing the amazing technology, but that they tend to, at one point you said, they have their model, but they take the deployment of their model for granted. They enthusiastically jump past a rigorous business process and straight into modeling, right? And so it just stays in the lab. The business user, they won't commit that fraud because A, they really only care about what's going to move the needle for the business. But B, they have many, many mundane things in their operations which are costly, and they need help understanding how using this power can actually reduce cost. Let's take a second and maybe if you want to throw in an example from the book of the kinds of things that we do in our operations, which we kind of consider to be normal, but that's only because we as humans have very slow abilities to do computation. Things like loading a truck, things like figuring out what ad to serve. We are not good at figuring out what a few minutes or seconds or a few hours from now could look like. And as a result, the way we build our businesses is inherently inefficient.
Yes, exactly. So we talked earlier about predicting better than guessing and how that's valuable. And I call that the prediction effect. That a little prediction goes a long way, because there's a big difference between randomly guessing and having no particular way, at least not scientifically or empirically, to target and make these decisions on a per case basis, and having something that's at least directionally in the right direction based on empirical evidence. And that's what we're doing. This is empirical science. It's learning from that data. It's learning from history. Data is an encoding of experience. It's a long list of prior events. So when you apply machine learning to an organization's data that it's accumulated, you're learning from experience.
Are you saying that their experience could sometimes even work against us? So, if a model were to be deployed and the model says, do something in a way that doesn't seem intuitive, that a human will, hit the red button and say, okay, we're pulling you offline for a second, ML. I'm going to do it the way I've been doing it for all these years. You're not going to tell me how to do it. Oh, and by the way, I'm not going to enter into the computer that I changed my mind. And so now we've got the digital world of the model and the real world out of whack with each other. Are you saying that that's a bad thing?
I don't want to sound, yes, but no, I mean, often it is about.
Well, I'm just pointing out we can be sometimes the wrench in the machine.
Absolutely. But I don't want to be a zealot and say always trust the machine, right? It depends on that's sort of an abstract question of when do you draw the line and say, wait a minute, there's something wrong here. I don't want to trust it. I mean, and this isn't a scientific question, right? Is the science is where you've got a lot of data and you're optimizing efficiencies. And that's the whole point of using technology. But then there's sort of a higher level where you're kind of like, oh, where did something go wrong? Did the world change enough that what was learned yesterday doesn't pertain today? Is there all of a sudden a pandemic or something? I mean, we all have these experiences, right? Sometimes you'll double guess the GPS driving instructions and think, I think I can go faster the other way. And if you're like me, you might have tried that a few times and realized, you know what? It never pays off. I always find out there was traffic where I didn't expect it, and I should have just followed what Google told me to do on Maps or Waze or whichever app you're using. It can work the same way, right, with any of these projects. But in general, yeah, this is about empirical science over the gut, and it's about acknowledging that a machine can learn from a much greater number of examples than any one human can.
Slipping to the other side, though, there might be people who think, well, this is an IT area, and in IT investments, like when we've been asked to buy faster servers or more storage, that's, we spend the money, the process is flipped from the old to the new, and immediately we're seeing a positive ROI. Do ML deployment projects work that same way? Is that a realistic expectation to have of them? Or are we missing a big part of it, like the humans that are involved in thinking on the project of how the ML will be deployed, and that counts just as much for the success of the outcome as the actual ML itself?
Yeah, I think humans are a lot more important than machines. And I mean that on all levels.
Right.
The machine, what we're talking here is about one of the last main remaining points of differentiation, which is learning from data to predict and acting on those predictions, because organizations are already relatively efficient in certain ways, right? I mean, major competing corporations, they tend to come very similar to one another in terms of their offering and their internal operations. So this is one of the last remaining points of differentiation on top of what was already created manually by people. And if you want to look at a particular project, like let's say you want to target marketing, it's humans, or at least human guidance, that created the content of the marketing that you're targeting in the first place. So you might be choosing, which content, which product to recommend, which creative to use for this particular customer, or whether or not to provide this retention offer that includes a discount and in any other way tries to seduce the customer to stick around. But that was created with humans very much in the loop. Now we're just targeting it. That's where the number crunching pays off. That's where you can act on science. That's where you've got enough kind of systematic rote collected data over a systematic process that you're going to continue, and that you can now continue in a more efficient way or effective way. So yes, I mean, this is all about augmenting, right? Which is a bit of a different message than the one that we're getting on in the media these days around all things quote AI,
Yeah.
where especially with the advent of generative AI, where it's so seemingly human-like and remarkably so that very quickly people jump on the message that the machine is going to become human level in its capabilities, also known as AGI, artificial general intelligence, what I like to call artificial humans. And I don't believe in it in the sense that, although I don't think it's theoretically impossible, I do not think we're on that road. I don't see the advent of generative AI or any of the other developments as being concrete evidence that we're taking steps in that direction as amazing. So it's hard to keep these two ideas in your head at once. This
Yes.
stuff is so amazing and it can do things I never thought I'd see in my lifetime. I mean, I focused on natural language processing research. I was in that research group at Columbia for 6 years. I never thought I'd see it to be able to kind of scale across concepts and the use of human language the way it does now. But that's still a very different thing than when you really want to holistically compare it to what a person can do overall.
Yeah. There's areas where we can provide at least some structure. I mean, for me, I think the thing about general intelligence is machines just don't have right now the capacity to consider the breadth of how chaotic and unstructured a human's life is. And so without that, they do need some things to you say, okay, well, I'm going to give you a problem right now, but here's the box the problem is in. Please solve within that box. And if the parameters are all set up, and that's what we're actually going to get to next, is it will be able to help that. The thing I just want to help our listeners understand here, because this was a big point you made in kind of securing the upfront definition of what the business people would need out of it, is you said we need to kind of boil this down to a structured enough ask that the ML will give a binary response prediction. So it'll either say something will happen or something won't. Now, what I found fascinating in the way you framed it was you said we could, for example, bring in our own definitions. And this is a uniquely, creative pursuit. Is we could say, for example, I just don't want to know if somebody who comes to my website is going to buy, but I want to know based on this kind of experience I give them, can I get a prediction of whether they'll make a purchase over $125 in this session? So we get to decide all of the things that might be that final yes no, but we do have to leave it in the computer's hands as a tell me if it's a yes or a no.
Yeah, I mean, we often can frame it as a yes/no binary prediction goal. Not always. It depends on the project, but I focus on those almost entirely on those kind of binary examples in the book because most, or at least many, if not probably most, predictive AI projects do end up working with a binary goal. And it's often at least the best place to start at a first pass on a project. Many things can be boiled down to driving a binary decision based on a binary prediction. If they'll buy, then contact. If they'll cancel, then contact, offer a retention offer. If it's going to run out of battery, then replace the battery. It's such a widely applicable thing. Now, whether or not it's binary, the thing that defines the use case, the value proposition for any project is what's predicted and what's done about it along those lines.
Yeah.
And for marketing, for cross sectors, for all these different applications, even in healthcare applications, right? Is the disease going to progress? Are they going to be readmitted to the hospital? Then take a closer look before you discharge them from the hospital. Those are the kinds of, and that's binary as well. So this is a very prevalent kind of pattern across sectors. And indeed, that's central to when I said you need a semi-technical understanding. It starts with that notion and then continues with a greater detail along the lines of what you were just saying, as far as you need to really clearly define that yes/no prediction question. in all its gory detail. So, not just are they going to buy, but will they buy something with margins that are at least X within a time frame of at least 3, and not return within 5 months for a refund, et cetera, et cetera. So it's sort of like all the caveats and qualifiers. It could be like a long run-on yes/no question, but so it's not super technical, but you could consider it semi-technical. But the point is that the data scientists can't determine all those pragmatics in a vacuum. This is where business pragmatics come into play. And this is a perfect place, where a perfect example of why the business professionals affected by the project, involved with the operations, their business know-how and expertise needs to take effect here. They need to get involved in that level of detail of essentially defining what we're using the machine to predict. And it's very much guided by how those predictions will be used. Again, it's what's predicted and what's done about it. And if I were going to break down the 6 steps, the first 3 are basically defining those 2 things, as well as the metrics, which is the question of how do you measure how, quote unquote, how good the model is, how well it predicts and how much value it will deliver. And those are sort of pre-production. They kind of set the stage for the project. That you don't necessarily do them exactly in that order, but that's the gist, and that's the level of detail you got to get involved in.
And based on what you've just described, I hope that people listening understand and agree that the business person can absolutely be in the driver's seat on this, and that your book is a call to people. You're not too worried about whether they came from a computer science or a quantitative background or a business background, but if they're willing to meet in that common ground, one of them can actually get this thing to fruition. And they just have to kind of hybridize themselves a little bit. They need to be willing to understand that specificity or understand that nuance of the business. Things like, a return reduces margin. If they can come to that landing, they've got all that is needed for a successful deployment.
Yeah, I think the reason it feels like maybe they need to be coaxed to, hey, come on, get involved a little bit in the details, is because of like a really simple misconception, which is that anything detailed around this kind of project is necessarily super technical. But no, not at all. The super technical part is the cool, fun science part, right? That's what does it mean to learn from data? How do you derive patterns or formulas or rules that hold not just over the examples that you're analyzing, but in general? And then that way you've learned. And how do you put numbers on that? And what's the algorithm? So algorithm really just means what's the steps? How do you program a computer to do that automatically? That you can learn the gist of that, and there's a chapter of it in my book, without, just like any other science, astronomy and physics and quantum. There is a pop science view of that, strangely not covered, considering, again, I think it's the coolest kind of science. So that's what I've done my best to do in the books. But this new book, AI Playbook, doesn't get into that until chapter 5, because it's really step 5 of the 6-step process. And so it's a machine learning book that doesn't get into the real machine learning till the end. But the analogy I would draw, like you said, be in the driver's seat, is I'm a driver of a car, as I would imagine you and many of the listeners may be. And I know the concept of internal combustion, which is cool. Like, wow, they figured this out, and now these machines can push us around really fast. Isn't that cool? It's kind of neat. So I know about that, but I have no idea where the spark plug is. I never look under the hood, right? But I'm totally an expert on driving a car. I know friction, momentum, the way the car operates, the rules of the road, and mutual expectations of drivers. Analogously, to drive a machine learning project, you need that kind of expertise, the semi-technical, what's predicted, how well, what's done about it, and get involved in the project end to end so that it delivers a business impact.
Yes, it's that mixture of predictive power and business impact that's going to get us what we want, rather than picking the thing that has a lot of predictive power but makes no difference to the business. So, but where we're going to find out how to do all that is in the data, and that's where we're going to go next. But before we get there, take a quick break. I'll step away to address one thing that's been missing from Funnel Reboot: the ability to access the text of any show. I'm glad to finally announce that the podcast is now fully searchable and copyable thanks to the transcript feature in YouTube. Yes, YouTube. Now, if shows are audio only, they are all on YouTube. Whether you're looking for a specific episode, a topic, or want to search the full text of a show for a specific part, go onto YouTube, head to Funnel Reboot's channel. Okay, now let's get back to the show. So Eric, we know that data is what feeds, machine learning models and gives them the ability to make predictions. You point out that we've got to think about how we prepare our data, and you describe it as needing to be clean. Can you tell us what we need on that?
Cleaning data janitorial maintenance is perhaps the potentially most boring sounding topic that anyone has ever.
Let's dig into it.
Let's get into this. This is going to be amazing. No, but what's going to be cool is I'll just make a couple points that you'll be like, oh, that's not boring. And it's actually not as daunting or messy as you might think. So basically the data that you need, the data requirements, you need a bunch of positive and negative cases. Assuming we're still in this land of binary,
Yep.
We've got a yes-no prediction goal. You need sufficient number of yes/no. Now, it turns out that you almost automatically have that data potentially available are organically, because whatever the large-scale operation you're trying to make yes/no decisions around has already been conducted. It's a large-scale operation. So as a side effect of conducting business, you've been accumulating that data, and you've got plenty of positive and negative cases, right? History has spoken. Those are the learning cases. These customers canceled. These ones responded and bought. No prediction necessary. They're cases from which to learn. They're learning examples that together compose what's literally called the training data. So it's already labeled. You already have the right answer. And that's the input to machine learning software. There needs to be enough positive and negative. Now, of course, you often hear, oh, well, there's problems with the data. It's messy. It's noisy. It's got errors in it. First of all, it turns out that these methods tend to be really robust against noise. So if there's certain errors here or there, that as long as it's relatively consistent moving forward after deployment, and you start using the model and it's operating on data that has a similar, distribution or frequency of these types of errors, it'll continue to predict consistently as well as it was, which wasn't perfect in the first place. Again, this is predicting better than guessing. There's sort of a ceiling. Who's going to click, buy, lie, or die? We don't have as clairvoyance, as I mentioned, right? So it's not like you're hurting a perfect prediction machine necessarily.
Yeah.
And even in cases where certain prediction goals can be predicted with extremely high correctness and confidence. So is this a picture of a cat or a dog? Is there a traffic light in this picture? And that, of course, would be used for autonomous vehicles. Just like humans, machines now, because of deep learning, which is a kind of machine learning, can do that extremely well, oftentimes better than humans. But if there's noise, like let's say that's a foggy lens, whatever took the picture has a bunch of smudge on the lens.
Yep.
Just like a human, the machine can still tell, oh yeah, there's a traffic light in the picture. It might every once in a while create a problem, but it's not a deal killer, right?
Yeah.
And also you should clean the lens as a side note.
But your point was, if it's in the training data and consistently also in, let's say, real life data or our control data, then, that's fine. The machine doesn't blow a gasket over that.
Yeah, right. And now the one place where you do need the data to be, reliable is in those labels, the thing you're trying to predict that we're...
Eric, what are labels?
Right, the outcome. As I mentioned, you need a bunch of positive and negative cases. The mark on each example that says this is a positive case and this is negative. This is a customer who did cancel or didn't. This is a picture that does or doesn't have a traffic light. That's the label. So that's how you learn. That's how the machine learns, is because of the existence of those.
Yeah. And like, as you've been describing this, and while I was reading it, I kind of imagined a very simplistic, like a spreadsheet. And I know that
most of us in sales and marketing have done this. It might be a win-loss spreadsheet or a churn spreadsheet where we've kind of pulled in all of these attributes. And each record has been a row of a customer, and then along on the columns we have these attributes, and maybe they're pretty wide. And with that most famous at the end, did they stay or did they go? Something like that. But you point out that we have to get, again, pretty specific about how we are using each one of these, because that could introduce noise into the data if we are, let's say, bringing it in, the Western region, they happen to compile it this way. Central and Eastern do it that way. Or we are bringing in from machines, but maybe things like date formats and, smallish stuff. These things actually have to be dealt with. They're not trivial, because they're going to be needed by on a regular basis for a model that's doing its job. So we're kind of aiming higher than we would, let's say, with just a quick little whiteboard or a smallish little Excel sheet that is being used for this. We have a little bit more rigor to apply.
Yeah, I mean, there's always technical gotchas. If you go back 15 years, computers would be allergic to any typo. Right nowadays, it's got autocorrect and all that kind of stuff, and I think that those kinds of tools exist as well when you're preparing the data. But one way or another, yeah, you got to get it right, and you can't put diesel fuel into the wrong kind of car.
Good point. Yep. The other one is, I guess, that some of these things have nuances and significance that we don't think about. I'm borrowing here from Malcolm Gladwell, but he talked about how when you're doing something simple as running a hockey system, and he looked, in his research at how hockey players were recruited, and specifically how over time hockey players rose to elite levels, that when they were little kids, the year column, just the year of birth, January 1st, December 31st, was the main thing used. Now, this is by humans that are selecting it, but you can see how the same thing would get introduced into a model. And that, well, because over 12 months when you're 5 or 6, that's a significant period of time, that span of two kids that are 12 months apart, and whether or not they fall on that December 31st or January 1st line, they could be a lot bigger, taller, whatever, that ended up being something that hugely skewed all scouts and recruiters and teams and selection bodies. And you ended up having kids that were mainly born in the beginning of the year as your top line on your top teams. And that we did this. And so I think the point is well had, that we need to watch when we're bringing in these kind of data, that there are areas. Now, you highlighted even some ethical areas where we've got to watch when we're bringing in this data, that we aren't introducing biases or other issues that are either going to harm our model or make its effects pretty deleterious.
Yeah, it's never going to be perfectly fair, and it's unfair to people who were born in December. I'm familiar with that study you just mentioned, and I myself was always old for my grade because of my birth date. And growing up in Vermont, and we moved from New Hampshire, there's a change of date. I always felt like I really benefited from that. My toddler, we just figured out that he's going to be super old, sort of the real oldest end of the spectrum for his grade. I'm like, great, he'll have the same experience as me. Now, but the problem is, so now you can rectify that, right? So instead of working with the number of years somebody has been alive rounded down, work with the number of days, right? It's not
right?
rocket science, right? So do it better, fine.
Right. Exact age since birth. There we go.
But there's always going to be things like that, edge cases or what have you, where, again, the thing is only guessing often a lot better than a human, but it's still a far distance from a magic crystal ball. So to what degree do you care about those things? And do you care that it's being unfair to people born in December? Well, I don't know. I mean, life's not fair, but what if it's treating people differently based on a protected group, like their race or national origin
Yeah,
or gender? Well, that's a
exactly.
big different question, and that's
Or
where
a
the ethics.
proxy like their zip code, and
Right.
like the
Yeah,
example in house insurance with redlining.
exactly. Yep. So that's where the ethics, and in predictive AI, those are kind of where it becomes discriminatory or biased, depending. And those are subjective words. So you have to define it clearly what the intent behind those words are, and what does it mean when a machine is making a decision that's somehow affected by these things or one way or another. So it's kind of the wild west out there right now, but I take that area extremely seriously. I've published a dozen op-eds in the San Francisco Chronicle, a Scientific American blog, and all of them are linked in this one place. If you go to civilrightsdata.com, that's where I
Yes.
put my list of ethics are, and then some videos too that kind of help visualize some of the concepts in the articles.
Yeah, and I encourage people to go check those out. It is important to understand we're doing something with data that the prediction and more of what you said, the outcome, the action that is going to be taken based on the prediction. Of course, in a business setting, we want that to have a net positive impact on profit, but it can have other impacts, both intended and unintended. And we have to be aware of those. And as you say, we especially have to be aware of them if this is in the delivery of public services.
Mm-hmm.
When we're trying to put this into an actual model, um, you do delve in momentarily to the technical part of what it's actually doing when it's trying to get from your original set of inputs to an output to that, what am I going to say the dependent yes no is going to be. You talk about decision trees. Can you just tell us for a moment, kind of break that down, what a decision tree is doing? Because people will hear about neural nets and all these things, and I think you have a very good way of just giving a simple explanation for it.
Yeah, well, this is the part like internal combustion where you can get a gist of what it does, right, without being a full-on techie who's running the machine learning software and prepping the data
Yep.
yourself. Um, so it the purpose of the model, predictive model, that which is what you get from machine learning, is to take as input what you know about one individual case, like for a customer, all the behavioral and demographic information you might have, their purchase history, and then output that probability for whatever outcome you're predicting in this project. How does it do that? Well, it's a little computer program, right? Or a big one. It depends on the context. And it could just be a bunch of if then statements, business rules. If the customer lives in this kind of geographical region, urban versus suburban, and has made at least these many purchases in the past, and then they belong in a group that's maybe 5 times more likely than average to respond to this marketing, right? It's going to be some
Right.
kind of if then. That would be a business rule. The most popular way to encode those is what's called a decision tree. And a decision tree is basically just like a taxonomy. It's if then else statements if you've done programming. It's just market segmentation on hyperdrive and automated.
Yep.
And basically, if you visualize it as a tree, any path from the top, because these trees are always upside down, so any path from the top down to an endpoint is just one of those long if-then rules. So it's a way to encode a bunch of those rules together. That's a relatively simple approach. It's oftentimes quite effective relative to its simplicity. But then you've got more mathematical approaches, which take all these input characteristics, which are called independent variables. Um,
Hmm.
and you might apply math on them. And ultimately, the most popular, advanced, sophisticated way to do that is a neural network. So neural networks can be shallow, like they were for decades, or deep, as they've become more recently. That's known as deep learning. And everything that we see with generative AI is built on deep learning.
Right, but they all begin with that, if I show landing page A, then this person, according to these traits, my likelihood of a yes response to the offer is this percent.
Well, that's for business rules, including decision trees. The building block for neural networks is mostly a weighted sum. So if factor one is A versus B, then assign that a value of 5, plus their age times 0.03, plus the next characteristic times some other weight. So these weights are just what you're multiplying each factor by. Then you add them together. And that's the building block. How do you weight them? And then there's some what's called nonlinear. So it's not just adding and multiplying, but the first foundation is just a weighted sum. And then you kind of do that repeatedly through layers, sort of a network of those little building blocks. And that's a neural network. Don't be confused by the word neural. The comparison to the human mind should really only be taken as an analogy.
Okay, fair enough. Yeah. We're not so far along on us uncovering exactly how we think anyway.
No.
The use of this math as you describe, this is meant to obviously make our outcome, but that to get us to that final result that we're talking about, where we know that this form of math is providing a better result than guesswork, you point out that we've got to hold some data aside. Can you explain that?
Yeah, I mean, the training data, the cases that are labeled, the historical cases where you already know the outcome or behavior you're trying to predict, those are cases from which to learn, and it guides the formation of the model for whatever it is, whether it's a bunch of business if-then rules or a complex mathematical formula, encoded as a network to try to keep it organized with lots and lots of weights. Whatever it is, you're using that training data to guide the formation. And usually you're going through the training data repeatedly to continually refine the model. And the model could be any one of these kinds of mathematical structures. Once you're done and it's learned a lot, there's this sort of almost philosophical question, but it's also a very practical one. Has it really learned something? Or has it only kind of encoded or memorized or ascertained things that are particular to this set of examples? Even if the training data has 100,000 or even 1,000,000 examples, you may have a lot depending on the business context, but it's only a small number of possible examples compared to the sort of realm of all possible scenarios that you may encounter in the future. So it's still a relatively limited, finite amount that you've learned from. So has it only encoded something that's peculiar or arcane to those examples, or has it actually learned something that's going to pan out and do well in general? And the way you test for that is really mind-numbingly simple. You don't have to do fancy math. You don't have to worry about theory or anything like that. All you do is you've held aside the test data. You've quarantined a sample of data that wasn't used for the formation of the model. It didn't get to cheat. It didn't learn from those. You've forsaken the ability to learn from them because you've held them aside strictly to test. So now when you try the model out on that set of examples, it's a way to objectively estimate how well the model will apply in general over unseen cases.
Yeah. So that kind of, if it's fit too tightly to the test data or to the original data, the other data will purge that out. It'll reveal, oh yeah, no, it does or doesn't understand or seem to have the a grasp of what the actual changes are, and that it could handle the next record that comes in tomorrow.
Right.
That's, so are we talking something like 20%, 30%? It's not a huge amount.
Yep, it's usually 20 or 30%, but that can vary greatly. But yeah, that's the rule of thumb. It's usually 20 or 30%.
Cool. And so let's say that we do get all the way to deployment, that we have, kept our leadership appraised of this the whole time. We're actually now letting the model instruct humans, or sometimes maybe replace humans in the decision and outcome. And you describe us having to kind of be aware of a slow burn here. We absolutely want to track whether or not we got that business result we were, aiming for, but that we shouldn't be too impatient about it, right?
Um, I don't know. Depends on the context. I mean, we should all be more patient. But what do you mean? Do you mean sometimes it takes a while before you can see the benefit of the project?
Exactly, and that the value
Yeah, yeah.
accumulates.
Oh, for sure. Yeah. I mean, you need enough examples and let things go. And also depends on the deployment, right? I mean, if you're targeting marketing, that's often you could often consider that decision automation because the predictions from the model are going to automatically, without human involvement, make a million yes no decisions of who should and should not be included on the next marketing campaign. Then,
Mhm.
after you conduct the campaign, whatever your time window is for responses, it could be a week, could be 3 months. It depends on the nature of the business, right? But it's finite. Whereas with decision support,
Yeah.
right, where the thing is providing information for salespeople or customer service agents to then use depending on context uh, in any way that they want. It's basically ad hoc. It goes back to human behavior and human decision making. It's just now they've been informed with something that might say, hey, this customer is at risk of canceling or might be more responsive to this product offer or whatever the suggestion that comes from the recommendation or the predictive system. Now you've got humans potentially now integrating into their process. So now we're talking about, well, a human practice, one that's going to be constantly evolving. And so certainly there are plenty of examples where you need a little more patience than was expected to start seeing the benefits pan out.
Right. And it's foreign. And so, you went through how, in one case in the book, there were training teams deployed into these centers where humans were making decisions. And the training teams would stay there. They would cajole. They would, like a SWAT team, just go around and try to remind people, oh, no, you don't need to do it that way before, or you seem to know or think you know more than the machine does on this. Let's move you to a place where maybe you're not so familiar with the process. We'll still keep you busy, but you're working with unfamiliar information, and at that point maybe you'll trust the machine's output a little more. That we need to basically handhold for the duration. That will definitely minimize the chances of somebody pulling the ripcord on this too soon, or of people not realizing the full potential of the project.
Yeah, I mean that proves that you read at least to one of the almost final chapters of the book.
Yep.
Good job. That you're talking about the UPS example where
Right.
they predict tomorrow's package deliveries in order to optimize, and they save tens of millions of miles driven and tens of millions of dollars a year with that system.
But it was agonizing to see how much work they had to do to just get someone to follow what the machine said.
Yeah. So there was cajoling a bit the way you described it. They're like, oh, well, this person thinks they're smarter than the machine, but it's actually hurting because they need to be trusting the prescribed, this package goes in this truck and this package goes in this truck. But that only goes so far. The strong arming, the executive authority. The real win was when they aligned incentives and sort of gamified it, put scorecards on it that followed leading indicators, rather, things that you can measure the success rates of in the immediate term. And had training staff grow and stay on site where these deployments were taking place for longer periods of time. So they really humanized the process and the deployment because it was one that was had to be implemented by humans.
Yeah. And yet, this is what the business people can do. This is what they're good at. And this will be, a huge determinant of success when you've basically got all of the hard work, all the technical work done. But this part must be included for us to actually realize the potential. So, um, Eric, the book took us through a lot of fascinating things. And if people want to find out where they can get it, or where they can find out more about you or your events, where would you send them?
Well, the book is at bizml.com. So again, bizml is the buzzword this book offers. That's the name, that's the titular playbook paradigm framework for driving and running machine learning projects, bizml.com. That'll also provide information about me and my conference speaking, my conference series that I founded in 2009, now called Machine Learning Week, with a new sister conference called the Generative AI Application Summit, coming the first week of June in Phoenix. And you can find out about that at machinelearningweek.com. And I have co-founded a startup, and we're looking for trial customers. And it's a system that evaluates the performance of predictive models in business terms, rather than just technical terms like how much better than guessing, but actually what's the profit or number of dollars saved that you'd get depending on the deployment of the model, which is a critical missing ingredient with most projects, where you're only looking at these technical metrics. But if you're not measuring the business value, then you're not pursuing business value, and you have a lack of visibility to the business side stakeholders. So that's Gooder AI. So make your AI gooder. Yep. So go to Gooder AI, gooder.ai if you're interested in becoming a trial customer.
Perfect. I do appreciate that you've put so many ways in here. I see you as a man on a mission with taking this, computer science born power and making it so that people on the business side can embrace it and find ways to deploy it. It seems like it's something whose time has definitely come. It's all around us, and it's time for us to kind of see things like a machine learning model sees them and realize that we don't have to make mistakes like we did in the past. We can do better, and that there's a very straightforward pathway to get there. Well, thanks again, Eric.
Yeah, thanks for having me on the show, Glenn. I really appreciate it.
Thanks for listening. Follow the show on Twitter at Funnel Reboot. If you like what you have heard today, please consider leaving a review wherever you get your podcasts.